Section 6.2 deals with solving triangles, right triangles, and their applications. When I say we're solving a triangle, it means find all angles and sides. Now pay attention to the naming convention. The angles are capital letters and the sides are lowercase. Lowercase b is opposite angle b, lowercase c is opposite angle c. Tools that can help us solve a right triangle is the Pythagorean theorem. In this case it would be a squared plus c squared equals b squared. Pay attention, it's the side squared, their sum is equal to the square of the hypotenuse. We also know that the sum of the angles in a triangle are 180 degrees. In this problem, they want us to find x. And no, I don't mean the cute, I found it, there's x. I want the actual value. Since it's an adjacent to an angle that I know, the cosine is adjacent over hypotenuse. So I can say the cosine of 65 degrees is equal to x over 8. 8 times the cosine of 65 will give me my answer. When you put it in your calculator, make sure your calculator is set on degrees, not radians. On a TI, you push the mode button and pick degrees. On the Casio, push the setup button and change it into degrees. I did 8 times 65 and got 3.381 for x. Let's make that standard go to 3 decimal places. This problem, they asked me to solve the triangle, so I need to find all the missing pieces. So I need to find the angle theta, side A, and side B. Theta, we know that the angles add up to 180 degrees. I have 90 degrees and 75, so that leaves theta to be 15 degrees. To find side A, I could use the sine of 75 equals the opposite, which is A, over 17. Do 17 times the sine of 75 in my calculator to get the answer. And I get 16.421. 16.421. And to find B, I can do the cosine of 75 degrees is equal to b over 17, or 17 times the cosine of 75 equals 4.3999, so I'm going to leave that as 4.4. It's nice to put all your answers together, put a box around them, it's easy to find, rather than writing it on the triangle. For this problem, I have to find angle measures, so I will need to use an inverse to get there. Since they gave me, if I want to find theta, I have an opposite and I have the hypotenuse, so I know the sine of theta is equal to 6 over 12, which is 1/2, and from my special triangles, I know that a sine of 1/2 is 30 degrees. If I did not remember that, I would use the second button on my calculator and hit sine, which gives you sine to the -1. That represents the inverse, not the reciprocal. There is a difference. So in my calculator, I could enter inverse sine of 1/2, and the calculator would tell me 30 degrees. If I know theta is equal to 30 degrees, I can subtract that from 90 and get b to equal 60. I still need to find side A, so I can use any of those angles, or I could use the Pythagorean theorem that says 6 squared plus a squared is equal to 12 squared. So a is equal to the square root of 12 squared minus 6 squared. 12 squared minus 6 squared, take the square root, and I get 10.392. So 10.392 is A, I have theta is 30, and beta is 60. The problem states a guide wire stretches from the top of an antenna tower to a point on level ground 18 feet from the base of the tower. The angle between the wire and the ground is 63 degrees. How high is the tower? I did this problem on purpose because people don't understand what a guy wire is. Here's my tower. The wire connects to the top and goes to the ground. That's the wire. All it does is hold the pole from falling over. It says this is 18 feet. They tell me the angle between the ground, this is the ground, and the wire is 63, and they want to know how tall the tower is. So now I can use my trig ratios. I'm looking for an opposite, and I have an adjacent, so I know the tangent of 63 degrees is equal to x over 18. 18 times the tangent of 63 is equal to 35.327 feet. Don't forget your units. Angle of elevation and angle of depression all rely on the horizontal. This is the horizontal. If you look up, you have an angle of elevation. If you look down, you have an angle of depression. The most common mistake is, here's a flagpole, the birdie's up here, and he sees a worm down here, and the problem tells you the angle of depression is 30 degrees. Remember, here's the horizontal, 30 degrees is here, not here. 30 degrees. Angle of depression. Two boats lie on a straight line with the base of a lighthouse. From the top of the lighthouse, 21 meters above water level, so this is 21, it is observed that the angle of depression to the nearest boat is 53 degrees, and the angle of depression to the farthest boat is 27 degrees. How far apart are the boats? So we're looking for x. If we separate the triangles, we can have one that looks like this. This is 21. This is 27 degrees. And we can find this total distance. If that's 27, this is 27. This total distance, A, would be the tangent of 27 is equal to 21 over A. Or if we solve for A, you get A is equal to 21 over the tangent of 27. From my calculator, it tells me that that is 41.215 meters. If I solve the other triangle, it goes like such. This is 53 degrees, this is 21, and we can find this value B. If that's 53, so is this. So the tangent of 53 is equal to 21 over B. Or B is equal to 21 over 53. Tangent of 53. My calculator tells me that B is equal to 15.825. If I subtract B from A, so 41.215 minus 15.825, it will gives me the distance I'm looking for, which is 25.39 meters.